single field applications engineer at TI may influence up to $20 million to $50 million in design decisions every year. That's often just by recommending one op amp or one buck converter. You may be asking yourself, what is a field applications engineer? That's what I was asking myself a year ago. And so I went and did an internship with TI, one of the companies that invests the most money into their sales engineering department, just to figure out why it's so important and what I can learn about being a field applications engineer. Basically, a field apps engineer is the bridge between the customer and the company they represent. So not only do they represent the company's product portfolio and help a customer pick ICs from that, but they also represent the customer to the company and their needs and desires. And so you need to have really good technical depth and technical breadth. You do anything from IC selection to integration into a schematic and all the way to board bring up and, mass production support. During my internship, I started off by learning about power electronics. Why? Because power is needed by everything. Everything needs some sort of electrical power to work. And so I worked on consumer electronics. So think like a docking station for a laptop. And in 6 weeks, I had to have a buck converter designed. I needed to simulate and do in-lab tests. And I also had to present that to my customer in 45 minutes and basically pitch it, tell them exactly why this is the best design that they could get. So you can see here, what I first had to do was research. What is a DC to DC converter? What is a buck converter? Well, think of biking down a really steep hill. You have all this momentum that can build up. You have this really high speed, right? But you're gonna be braking every once in a while, just to make sure that you keep this constant speed at the output that's regulated. Basically, a buck converter steps down voltage. In that same manner, it regulates and makes sure that the voltage that's being supplied is constant and at this good value for the rest of the electronics to use. From there, I learned how to navigate some of the TI resources, such as the website, where I learned about the product portfolio and how to spec those out for a customer. Then I did some simulations with PSpice, and finally I went to the lab and did my efficiency tests, beating all the customer specs and ensuring that design will actually work for them. Now, at the end of the internship, I did my 45-minute presentation, and what that concluded was, I had this customer, and how do I get them to understand that this design is what they asked for and what they needed? And at the end of the day, communication and technical communication was the most important part. How do you convince someone? So anytime you ask yourself why you're taking an ECE communications class, remember how important field applications engineers are.